Cool. All right.
Welcome to CTF 101, as you said. My name is dayt0n. He pretty much covered it. I am currently doing red team and software development work at Cybearity. I was the UAH Cybersecurity Club president and CTF team captain. I was on the US Cyber team. I've done a fair number of CTFs. I really started out in cybersecurity doing iOS hacking. So I released this one command that you could run on your phone, and it would change the color of the Apple logo. But it had the unintended side effect of hard bricking some phones. And so that was like my first experience with how the community reacts whenever you drop something like that. I really like writing programs in Rust and Go, and I also enjoy spinning up new network infrastructure and just building things in general. Those are my links, socials, whatever you want to call it. So for this talk today, you're not going to learn everything. Some parts are going to get pretty deep into the weeds, so just stay with me on that. And feel free to ask questions after the talk. So what's CTF? I'm glad you asked. It's the cybersecurity version of real-life capture the flag, but it's got a few key differences. So each team does not have their own flag. There is just the organizers' multiple flags, and multiple people can get the same flag. It's great for taking a deep dive into cybersecurity. And there's different formats like attack defense, where everybody is attacking everybody and everybody's defending against everybody. There's full pwn, which I'm sure a lot of you have tried before, hack the box, try hack me, stuff like that. There's defense only, where you're being attacked by a red team, and you and a bunch of other teams who are only blue team have to make sure that you don't get compromised. It's really all just gamified cybersecurity education, and it tricks your animal brain into learning something, because it's a lot more difficult to just say, I want to sit down and read a book about cybersecurity. It's a lot easier to just play a game and compete with other people. So Jeopardy is the type of CTF that we're going to be doing here today. Usually there's different categories like web exploitation, reverse engineering, binary exploitation, cryptography. Sometimes there's cryptocurrency challenges. We won't be doing those today. Forensics challenges, and then miscellaneous for anything else that doesn't really fit into one of these categories. A lot of CTFs have dynamic point systems. We'll be using a static point system tonight. That just means that the points won't change depending on how many people solve the challenge. And they usually run for 24 to 72 hours, long enough for a weekend. So how do you get good at CTFs? I recently started bouldering. I really wanted to get good really fast, but I realized that's not really how it works. I asked my friend, who does a lot more climbing than I do, how can I get good? And I was thinking maybe he was going to say hangboarding, where you just pull your fingers and put all your weight on them for multiple times a day, multiple days a week. He said no. Do I constantly squeeze a stress ball to strengthen my hands? No. Some new gym exercise? No again. The answer on how to get good at climbing is you just climb more. You just do it more often and more consistently. And with CTFs, that's what you have to do. You can do these practice CTFs like Pico CTF, Try Hack Me, Hack the Box, or Over the Wire if you need to enhance your Linux skills. But they're not as good, in my opinion, as just playing a CTF and being competitive with other people, because that's really what drives me and might drive you. CTFtime.org is where you'll find a lot of CTFs. There's usually one going on every single weekend. And it's a good idea to get like-minded people to join you so you can form a team and you can actually play against other people. And by doing a public CTF, you get thrown into the deep end, which forces you to learn. And the main thing is to just be consistent. And whenever there's not a CTF going on, you could try Hack the Box or try Hack Me or Over the Wire in the meantime. So a challenge in a CTF can have downloadable artifacts, so like files or remote components that you connect to a web server or some other service that's running on a remote server somewhere. They rarely have hints, at least in the public CTFs that I've played in. And if they do, usually have to trade points for hints. So with the downloaded artifacts, you never want to run them on your own computer. You always want to run them in a VM. I've seen where they put actual live ransomware in a CTF, and people have nuked their computers because they ran it outside of a VM. So don't do that. We don't have live ransomware for today's CTF, but you never know. And the remote components usually look about like this. So it has the host, a colon, and then the port, or it might say like NC for netcat, which is a utility that allows you to connect to a server that's just like a text-based exchange. And the flags usually look like this. So it's some identifier that is associated with the competition, and then it has curly brackets, and then some like cheesy phrase in there that's all leet speaked, and it changes each challenge. So once you find one of those, you submit it to the scoreboard, and if it's correct for that particular challenge, you get points. And usually flag or solution sharing between teams leads to disqualification. Tonight, that's probably not going to be the case, just because this is going to be like sort of a big team effort. And with CTFs, you can either go wide or you can go narrow. So you learn everything as you go, and CTFs require you to learn a lot about a lot of different things, but you can choose to specialize, which a lot of people do. So some people might be a web exploitation main, or they might be like a reversing main, but they still know a little bit about all the other categories. So this is just some general advice for every single category Jeopardy-style CTF. You fortunately need to know how to program, at least a little bit. Like you need to know about if statements and loops. Python is really the easiest language to use for CTFs. There's also a ton of libraries that people have made that make it a lot easier to do CTF challenges with Python. And can I just get a show of hands of how many people have used Linux or know their way around Linux? Okay, good. So you definitely need to know at least the basics of Linux. And if you don't, I recommend Over the Wire's Bandit, which walks you through a lot of the basics and you build up to the more complex commands. And these are just some of the tools that I use. I think we have Kali VMs here tonight if nobody has any. I normally just use VS Code and remote SSH into a VM, so then I can code and do everything inside the VM like I'm on my actual laptop. Obsidian is great for note-taking. Docker, a lot of challenges require Docker and containers. CyberChef is actually made by the GCHQ, which is Britain's version of the NSA. So it's a public resource, but it's essentially a CTF multi-tool. And it'll definitely come in handy tonight and in any other CTF that you do. Also Google, gonna need to know how to use Google. And large language models, they can help, but I don't recommend it if you're just starting out. If you've been doing CTFs for a while, use them, absolutely. But use them with a high degree of skepticism. There's really no free lunch with AI, so you probably should ask questions around the problem space and not just feed it the file and say, what's the flag? Because then you're not actually learning anything, and then it's kind of like, what's the point? Why am I doing this? And another thing is just a lot of AI companies now, their current business model relies on sort of de-skilling you to the point where it's difficult to do your job without the AI, without the subscription. With CTFs, it has to be something that you enjoy if you really want to get far. And so I just think it's important to learn what you're doing with that. So we'll just dive into some of the different challenge types. Web exploitation. So you'll learn networking basics, all about HTTP, so much about HTTP. You'll get comfortable with HTML and JavaScript, and you'll learn sort of what the life cycle of a web request is. The tools that you can use for web exploitation challenges are Burp Suite, Inspect Element, which is actually a lot more useful than you might think, Python requests, which allows you to programmatically hit web endpoints and use the data that you get back for challenges. And then you just need some kind of website that receives requests as well if you're going to do something like cross-site scripting attacks. This webhook.site is one of the newer ones, but there's literally hundreds. You can just Google webhook website. And we're just going to start at the networking basics here. If you're not already familiar, a server is just the bare metal machine that's running multiple applications. So that thing right there that's spinning on the ground is a server. But it probably has multiple VMs inside it, and each of those VMs has an IP address. Those IP addresses can be mapped to names, human readable names, through the domain name system, or DNS. And for instance, a single web server can have a web server running on port 443, email on 587, and SSH on 22. And just as an example here, I did a lookup on the uah.edu domain, and that's the IP address that is associated with that name. And then you can run nmap on that, and you can see all the services that are running on that server. And so those are just ways that you can interact with the server remotely. Here's just a little bit about HTTP. It's a client-server architecture, and there's different methods, so different ways you can ask an HTTP server something. So you have the get, post, put, patch, all those different ones. And then after you make that request, the server will respond saying, okay, yeah, I got your stuff for you right here, and it will say 200. 401 means you're not supposed to be here, and then you get all the way up to the 500s, which means there's something wrong with the server, and if you ever see that in a CTF, you probably need to contact the admin. And there's a lot more to HTTP. There's headers, user agent, stuff like that. I recommend just checking out the RFC for HTTP. You can learn a whole lot about how the internet works through that. Here's just some of the common web exploits. So you have cross-site scripting, where a user can input data onto a page, and that data is saved for other people to see. And that data can be malicious. So here, if there's like a name box, and you put in quote / bracket, and then just a JavaScript tag with a piece of code in there, if other people look at that page and that's not properly sanitized by the web server, they will get that alert box on their screen, and there's nothing that they can do to stop that. We also have server-side request forgery exploits. So this is where a server says, hey, if you give me any link, I will go visit it, and I will return you data from that link. So here's just an example. On AWS EC2 VMs, they all have this metadata endpoint, and there's actually like an endpoint on that metadata where you can get security credentials for an admin user for that machine. So if you have some type of exploit against a CTF challenge running on AWS and it's SSRF, you could probably hit that and get control of the VM. And then you also just have local file inclusion and local file disclosure. So a lot of people kind of lump these two into the same category, but it's basically just telling the website, hey, I want this file, and then it either includes code from that file on the page, or it spits out whatever you tell it. So you can do a little directory traversal there and get to Etsy password. And sometimes for CTFs, they just leave the flag.txt on the main web server. So be sure to check for that. I'm not promising that that's going to be in the CTF today, but it might. And then also robots.txt. That usually has endpoints that maybe people don't want you to go to, and you should go to them because it's a CTF. So I mentioned this earlier, but this is Burp Suite. Really, you can see the web request here that I made to Google, and then you can see up in this top part every single request that came after the initial request to Google, and you can see the response. And so this is just what HTTP looks like under the hood, sort of. And what's cool about Burp Suite is you can take this request that you receive and you can modify it and then send it back again and see what type of output the server gives you. But yeah, this is like the webmain's holy grail of a tool. So we'll get into reverse engineering now. With reverse engineering, you'll learn all about assembly code, a little bit of C, C++, symbolic execution, and debugging code. So the tools that you'll use for this are a disassembler, an anger instance, which we'll talk about, Linux strings. Please always use strings if you have some type of forensic file or reverse engineering file that's given to you by a CTF, because more often than not, you will just find the flag in there because you'll be parsing out the strings and you can just grep if you know what the flag format is. Godbolt, that's a pretty good website that shows you all the disassembly views, and then a debugger as well. So if you're not familiar with the compilation process of C or C++ code, so here on the left you have just plain source code. You can definitely read that. And then assembly code, which is a little bit harder to read, but you get a little bit closer to the CPU. And then the final step in the compilation process is when you get machine code, which you probably can't read unless you're Linus Torvalds or someone crazy like that. But it's just a bunch of hex, and you need a way to view that, especially for CTFs, because whenever you have a reversing challenge, it will be given to you in this machine code binary packaged way. So a little bit on assembly. It's, again, the closest human readable way of representing machine code. All CPUs have these things called registers, which are little blocks of memory inside the CPU, and those blocks can be used in instructions. So let's just say, for demonstration purposes here, these are the main operations of a CPU. There's more, but this is really the basics that you should understand. Here I have a move of the value 1 into RAX. So the CPU will move that value into that register, into that block on the CPU, and store that for later use. You can do math. You can add 1 to RAX. You can subtract 1 from RAX. You can do a comparison against RAX and 1, which will then set some magical bit that you don't really need to worry about, but you just need to understand that it's there for abstraction purposes, saying that this comparison was either greater than, less than, equal to, or not equal. And then you have jumps, where the CPU can jump to different addresses in your code, or you can have a conditional jump where, let's say you do that compare, then you can say jump to this address if that comparison was a not equal. Really, reading assembly is a lot more important than writing assembly when it comes to CTFs. So do not worry about writing assembly. Just know the basics of assembly, but even then you probably don't need to know that much, because a lot of disassemblers today come with decompilers, which will show you something that looks pretty close to source code whenever you disassemble a file. So here I just have 2 examples. Well, this is the same file. The first one is the assembly code view of a compiled file, and then this one is the pseudocode view. So you can see this main function here does a puts, which is a print hello world, and then it returns and it does nothing. But then if you look over at the assembly, it does all this other stuff and moves a ton of other data around, calls your puts, and then does some other stuff after or before it returns, and then it's done. But of course the write is a lot easier to read, and that's probably what you'll be looking at most of the time. These disassemblers can range anywhere from free to you should just put a down payment on a house instead. So Ghidra is free, taxpayer funded, made by the NSA. They open sourced it back in the late 2010s. I think it was like 2019, maybe 2020. That's free. It's written in Java though, so you have to install Java on your computer. So you could also just get Binary Ninja, which is $74 for students, $300 for everybody else. But, and I'll get to this later, Binary Ninja does have a free cloud option. So you can just go to their website, cloud.binary.ninja, and it's just a free decompiler and disassembler online. And you can use that for the CTF today. And then you have IDA, which is super expensive. I'm not even going to put the price on here, but that's the down payment one. So whenever you're doing binary exploitation or pwn challenges, you need to be able to debug a program. So normally whenever you hear the word debugging, you think of a programmer who's debugging their own code. But for CTFs, you're debugging someone else's code. There are a lot of add-ons that you can get for GDB, which is a Linux debugger. I like to use this final one here, which is all of the previous three combined. So it will map like GDB-pwn-debug to the pwn-debug version of GDB. And I believe I have a screenshot in here of what one of these enhanced debuggers looks like. If I didn't have all this stuff, I would just have to manually say that I want to inspect the disassembly, each register, but because of these plugins, I can see everything I need to see about the program at once. And then I can step through it or call other functions if I need to. But you can also just cheese a lot of reverse engineering challenges. Like I said, you can just use strings. So here I have an example. You wouldn't get this C code here, but it has the flag in there. Compile it down, and now you can't read it because it's in that machine code version, but if you just run strings on it and you grep for the CTF flag format, you'll see the flag printed out right there and you can submit it, and that's like a free 100 points. You could also run GDB, which is that debugger, and you could break right before there's some sort of string comparison if they're asking you for a password or something like that. And then you can just print out the stack and the registers and everything, and you can see what they're about to compare your data to. And that will probably be the password or the flag. So this is just sort of an aside, but there's a cool like mathy thing going on in the reverse engineering world right now. These things called SMT solvers. So if you remember these systems of equations, it's kind of like that, but not exactly like that. So these bullets here, if anybody figures out what y is while I'm explaining this, just shout it out. But you basically have a lot of different conditions for what something is going to be, and then your solver will go and figure out what that value possibly is. So here I have y is greater than 6, but it's less than 100. Yes, 7. But yeah, so you would just essentially feed something like this to an SMT solver, and it would output 7 for you at less expense than a pure brute force approach. So you can use these in a program context as well. So imagine that a certain instruction's address in a program is X. Let's just say like the print flag function, and you have to provide an input to get to that function. The solver says what input is required to get from the start of the program to X. Well, there's a lot of conditionals and jumps and loops and everything in there before you can get to X. So it will basically figure out what it needs to do to get to that point and what input you'll need to provide. And you basically don't have to lift a finger. And this goes into symbolic execution a little bit, which is, it's a newer concept, but there are tools out there now that can take your program that you feed it, your compiled program, and you can break it up into little pieces, and it will walk through those pieces and run them in like its own little context. So Anger combines these two concepts, and it uses symbolic execution to run the small portions of compiled code, coupled with the SMT SAT solver technology there. It makes rev challenges a lot easier. So here's an example. So if I have a reverse engineering challenge and it decompiles to something like this, I'm not going to want to sit there and write out, okay, I know X can't be this value, but I know it can't be this value, and I need to get to here. And so really, I'm just not even going to try, and I'm going to write a Python script for me, and I can say, I want to get to you achieve level 5, and the address ends in 62. I don't want to get to the you are not lead enough that ends in 78. So I can tell Anger, I don't want to get here, but I want to get here. This is how much input I have to provide. Tell me what I need. And then you can just run the program, and this figured out what the flag was in about 10 seconds on just a normal laptop. So we'll get into binary exploitation a little bit. In my opinion, it's the real life equivalent of magic. You'll learn about computer memory, so stacks and heaps and all the protection mechanisms that computers have these days. Assembly language again, basic algebra, C, C++, or Rust and Go if you're unlucky, because those do not disassemble very well. Tools that you'll use, a disassembler again, a debugger. There's also a Python library called Pwn tools, and that allows you to programmatically exploit challenges. So isn't this just reversing with extra steps? It is. So the extra steps are usually the flag is not on your machine in the challenge file. It's in a remote location, so you'll have to connect to it remotely through netcat or something like that. And they're usually compiled in C code because C decompiles well, it disassembles well, and C also has a lot of opportunity for memory corruption vulnerabilities. So here's just like a little taste of memory corruption. So you have stack and heap based overflows in C code. The stack and the heap are just two different types of memory that the computer uses. This is just an example of the stack. So let's say that you have a variable that can only hold 8 characters, and you ask the user for input, and that user inputs more than 8 characters. Well, the way computers organize memory is they just put everything side by side, kind of, but for our purposes, that is what's happening whenever you're exploiting a program. So as you can see here, there's other memory right beside it that's critical to the execution of the program. And if you write into that, you're dead. Your program's dead. It's not coming back. But if you know what you're doing, you can write the correct value to the correct location. And let's say that there's an address that's holding another address, and that address is where the program jumps to on the next instruction. If you overwrite that with a different address, you take control of the program's flow, and you can tell it where to go and where to jump to. This is mostly what you'll see in Pwn challenges, is some kind of redirection like this, or return-oriented programming. There's other different types of Pwn vulnerabilities. There's logic bugs, format string vulnerabilities, integer under and overflows, and use after freeze. Use after freeze only occur in heap memory. And this is the Pwn tools that I was talking about earlier. So as I said, it's a Python library. You can programmatically interact with the binary or the remote challenge. So here I know that my payload is going to be to send a 3, and then 0x47 A's, and then an address. And so basically what I'm doing here is I'm writing to that memory field that holds the next address. And whenever I do that, I get a flag. And so this way I don't have to like manually type out bytes every single time. This is my least favorite category, cryptography. What is that? It's a pig pen cipher, but getting into cryptography, I had no idea what that was, and I was like, I feel like giving up now. But the things that you'll learn are math, a lot of other math, how one weak component can break an entire encryption system, and also the unknown Pokemon alphabet. You'll learn that by heart, because sometimes CTF challenge makers want to use that as a crypto challenge. The tools that you'll use are RSA CTF tool for basic RSA breaking challenges where somebody has used some weak variable. Sage, which is a Python. You can use it in Python, but it's like a math library. Python again, of course, and then a JSTOR subscription, so you can read about all the novel crypto breaking techniques that people are finding every day. For the forensics category, so this is the needle in a haystack category, in my opinion, and sometimes the haystack is inside 8 other encrypted haystacks. So I feel like I kind of get like a Russian nesting doll type of thing from forensics challenges. But basically what you'll learn are how to pull data from RAM snapshots on Windows and Linux. So for instance, you can view network connections and processes that were running on a machine whenever a RAM snapshot was taken using a tool called volatility. You'll learn about iOS and Android backup parsing for some challenges where there's mobile data. And you'll also really learn how to make sense of the PNG file structure in a hex editor. If I had $1 for every time I had to open up a PNG in a hex editor and look at it manually, I would have about $30. So the tools, again, you'll use volatility. There's a ton of like PNG fix or PNG check tools. Sometimes challenges will just be a broken PNG that you'll have to go and manually fix or use one of these tools on. And finally, a hex editor. So the hex editor is going to be your best friend for forensics challenges, along with strings, of course. And if you stare at it long enough, you might see something. So with a hex editor, you can modify files 1 byte at a time, or you can just see what's going on. You can get a peek into what all this gibberish translates to in hexadecimal. So steganography it's kind of a forensics. A lot of times people will put it in a miscellaneous challenge. But steganography is the process of hiding secret data in seemingly innocuous data. So here, for instance, I have an image. I believe that's Bob, the minion. And there's a tool called steghide where you can hide and extract plain text data in a JPEG or a WAV file. And so I didn't put a passphrase on this, but you can put passphrases on them. So sometimes you might have to like brute force something if it's steg hidden. But here you can see Guru's been gone for 12 days. He wanted to tell me that, but just in picture form. So this is where it gets a little bit philosophical. We're out of the Jeopardy overview now. So general advice is there's always a solution to a challenge. If you think it's impossible, it's not, unless it's been like 30 hours and nobody solved a challenge, it might just be broken. So don't be shy and reach out to an admin if you feel like you need to. Take breaks and do something mindless away from the screen, because trust me, if you do this, you will just have ideas on something that you could try again. Do write-ups and publish them. So in the CTF community, there are a lot of people who write up how they solved a challenge, and then they'll post it online on GitHub or on their website. This is just good practice, and it helps solidify a lot of the things that you learned during the process of solving a challenge. And don't be afraid to struggle while you're solving a challenge. That's really where you learn, in my opinion. And work on what feels the most interesting to you. So if somebody wants you to do forensics and you don't really like forensics, but you really like web and there's still an open web challenge, try that. You really want to use the gamification of learning to your advantage. And finally, beware of burnout. So I said do this consistently, but I've done it consistently to the point where it's like an everyday thing, and that can quickly lead to burnout. So do other things, but also do CTFs. And being a pro CTF player is cool, but doing CTF for CTF's sake is not sustainable, in my opinion. CTFs are about learning from and being comfortable with your own mistakes, gaining knowledge in areas that you would have never thought that you would gain knowledge in through school or work. It's about being able to handle any problem that's thrown your way. And finally, knowing really how a computer works as a whole. Sometimes I've had people ask me, like, what books do I need to read to get good at CTFs? You don't. You'll never read your way to deep knowledge and practical skills, but it can help, especially if you do something hands-on along with the reading. You can build a really great network with lots of smart people through CTFs. I've played on teams with people who are so much smarter than me. It's not that difficult to do that, but it is still, it's a lot of fun whenever you can just watch somebody lock in and solve a challenge that would have taken you hours in minutes. And finally, you should want to build skills and be adaptive. This goes for CTFs, work, and all other aspects of life. And just follow the dopamine. Do what feels right in terms of learning in CTFs and pursuing your goals in life. So the CTF time is now.
Yeah. Well, cool.
Thanks.
Thank you very much.